teaching store.
Is it just called a teacher store?
It's called like teacher school supplies or something like that.
You write inside your notebook?
Hello.
How's it going, Ben?
It's going good. And you?
Not bad, not bad. One more day, it's Friday.
Oh, dang, I still have to run tonight. I don't want to run.
Where are you going to run to?
Around a gigantic course for 3 hours.
It's our last meet today.
Yeah.
Where is it at?
It's down the road of the golf course.
Disc golf.
You're going to run the golf course?
Well, it's the kind of golf.
Is it the same thing? I'm trying to remember. I don't remember seeing any disc.
Down that way. And
Yeah.
then you like go up against the fence of Woodman Hills Elementary.
Right.
And then you go up to Woodman Hills.
Okay.
And then come back down through.
All right. Well, how long is it?
It's supposed to be around like 3.2, 1.
You've run that distance before, right?
Yeah.
No big deal. Huh?
It's
pretty flat?
Kind of.
Okay.
There's one pretty kind of.
There's a bunch of sand that I hate running.
Yeah, there's like a sand pit that we have to run through.
All right. Any questions?
It was math.
Yes.
4, 11, and 12.
4, 11, and 12. All right. Jack, I'm going to try to do this, but it probably won't work, but we'll give it a shot. Man. Ooh, horrible.
What if Jack is being abducted by aliens?
He's not.
What?
Who's not?
You see the board, Ben?
Yes, I see the board. It's me.
It is you. Page.
140.
Oh, dang, there's a lag now. Ugh, looks weird. It's a slight lag.
Someone's not even for forward.
Like 1 second lag.
Like 2 seconds off. Have you seen
All right. Well, how do I do this? I don't want that to.
Oh, I do see this light.
You cannot minimize. Well, I need a white screen so that I can. Oh, I know what I can do. Aha! There we go.
Ah.
I've been trying to get the guy that installed this, so I would like a button so that I could go from the camera there to the PowerPoint. So I can just hit one button and the video will record either that using that camera or record off on my. Because right now all I do is basically go to PowerPoint and say record over the PowerPoint slides. All right, number 4. One of the triangles looks like this.
The other looks the same.
Not that far.
Not that 4? Oh, written exercise 4. All right, you're not going to like this one because it's actually really easy and you'll feel really dumb when I show you the answer.
Did I actually do it? How did I miss 4? No, I didn't.
All right, so we don't know the shape yet, but you can probably guess the shape is a
Triangle. A triangle looking thing.
it's a trapezoid.
So aren't all shapes triangles? So if I say triangle, I'm still
Oh, I hear
technically
you.
right.
All polygons can be made into triangles. That's right. And you're told that the diagonals are congruent, and I think that's it.
Yeah, that's right.
And you're asked to prove that this angle is congruent to that one. It's not right now, so you're asked to prove those 2 angles. Okay. Triangles are together. Pull them apart.
Isn't that 3?
No, there's 4.
There's lots of triangles there, but of the 2 triangles, right? I'm going to pull the 2. Well, I'll just draw it. I'm going to pull this one and this one apart from each other. See what I did? Okay. So we're trying to show that this angle is congruent to this angle. show that these two triangles are congruent, but we're told the diagonals are congruent. Okay. We're also told what? Well, the tops and the tops are literally the same thing, so we got that. Are we told anything else?
It's math.
We're told that that the two ends are congruent. Therefore, the triangle's congruent. So therefore, by Cpctc, these must be.
I said.
Like I said, it's not very satisfying when you do this because you're like, well, okay, duh.
I did SAS, but now I
There's
see
no
what
angle there that until we get to the triangle congruency statement.
Okay, that makes sense. All right.
Number what?
Well, number 12, didn't you just have to figure out what kind of triangle it was? Or the angles, what kind of triangle they made?
It says, why are they congruent by what method?
Yeah, what method? That's what it was. So like SAS and stuff like that.
That's a hard shape to draw. I wish I had a document camera. I would just project it. This thing does not erase. All right. QPR. QPR. I'm just going to draw the two triangles you're supposed to prove. This.
Why can't they draw it like that?
This is QPR.
Yep.
And you're trying to prove that it is congruent to TPS, which is its opposite. So it's like this. Is it T on top? No, it's P. P, where's T? Right or left? Well, clearly they both share P, so they has to be congruent, right? It's the same angle. Oh, that's not true. Never mind. It's just called P. They're not the same angle. You are given that angle 1 is congruent to angle 2. So between them, you're told that that's congruent to that. That's 1 and 2. You're told that 3 is congruent to 4. All right. I got to draw the whole darn thing. I thought I could get away with it. I can't. Whole darn
I
thing.
can draw the whole darn thing.
There's the whole darn thing.
Yeah, it's almost a diamond. Yeah, that looks so.
And this.
Yeah.
Okay.
An upside down.
So 3, 5, 6, 4. So 3, 5, 6, 4. And 1, 2. 1, 2. PQT. And RS. And is it XY? XY, something like that.
So QRP, SPT.
Say again? It doesn't matter, right? All right, so you're told that red marker, blue marker, 1 is congruent to 2. You're told 3 is congruent to 4. QRTS. QRTS. And you're trying to prove that QPR, you're trying to prove that this triangle is congruent to that one. Okay, well, we already have an S, right? But that's it. For me, I'm going to go back to the trusty. I should have drawn this first. I'm just going to pull the two triangles away from each other. So
the old trusty pull and switch.
All right, and we know that that's congruent to that.
Well, then they're just SAS. I mean SAS. Yeah.
This triangle right here.
Maybe. I might
See it?
probably dumb.
See that one? What kind of triangle is it?
Isosceles.
Oh, right.
Right. Isosceles.
This one, isosceles because of this. So therefore, what can you say about that?
It's yes. So S.
The middle one. So therefore, what can you say about these?
No, they're.
Well, that's this. So 1, 2, 3, 1, 2, 3, SSS.
Dang it! I did SAS again.
Now, I'll just say both ones you asked me to do, like I figured it out by just pulling the, well, this one I had to redraw. I couldn't see it. at first, and then I pull it apart and see it. Okay. Yeah? All right. What was the homework? Odds or evens for the
There's 1 through 9 odds
for the classroom? All right. One is, well, you can do it two ways, AAS or ASA. 3 is ASA. 5, 2 ways, SAS or SSS. 7 is nothing, and 9 is nothing. And then which ones are not proofs?
2,
5?
2, 5, 6,
Okay,
7.
5, 6, 7. All right, 5 is SAS, 6 is AAS, and 7 is hypotenuse leg.
Oh. Okay.
Because you see that it says it's perpendicular, so therefore it's right triangle.
Yes, but the weird thing is that I just went over with all of them. So,
Did I give you 8?
yes.
All right, 8A is yes, and depending upon SSS. B is no. All right, skipping 9, skipping 10. Let's do 10B, 10B,
I
10B.
think we did 10.
We didn't have it? Okay.
Yeah, we didn't have 9 either.
Didn't have 9, good, because those are both plans for proofs. So, and then I just did 11 on the board. What did we have? What did I give you up to?
12.
12.
You did 12.
I did 12 on the board? No, I did 11 on the board. So was I supposed to do 12? I thought you asked for 11. So 12, all right, let's look at 12 then. So 12, I'll take away all the blue.
Color shine.
12 says that 3 is congruent to 4. Oh, it's the same thing. 5 is congruent to 6. Not the same thing. I bet we solved the same way. And we need to do PQX. PQX, that's going to be this triangle, the small one, and PTY, this one. So just erase this. That's done the same way. So that and that. And we know that that's congruent to that. Okay, what else? You should be able to do this one now.
You could say that the 2 inner
Because isosceles triangle. And then
the outer one.
because of the same thing. I mean, it's literally the same proof. There you go.
Yes, I got
Oh, wait a minute.
No.
That doesn't say what we want to say. What does that say?
But
No, that says ASS.
Then it's a hypotenuse leg.
But it's not a right
It's not a right triangle.
Triangle, so then it'd be ASA or SAS.
there, I solved all
Hmm.
SAS.
Oh, okay. So this was actually harder. So here's the logic. Straight line, right? So this one and this one, there's a number right here. Could it be any different than that one? Because these two are congruent, and that's how you get this angle. So you get that, and then you have angle, side for that. There we go. That one actually was harder. So angle, side for 12. I had to think about that one. That's why I was young. And the nice thing is that most of the time the teacher book, I mean, it'll tell me all the calculation ones, but it doesn't ever tell me the proofs. So that gives me joy to do proofs. Otherwise, there's not much thinking involved when you can see the answers in the teacher book. All right. Let's, Then what would be fun to do today if I like proofs?
Oh no.
Oh, yes. Nothing but proofs today.
Nothing but proof? What about just a small bit of non-proof?
Yeah, there's no non-proofs today, it's just proofs.
Even in homework?
Even in homework.
Okay.
Period 1 told me that when they started doing their homework, it was way easier than the proofs that we did in class. We finished a little bit early. And they're like, wait a minute, these are way easier than the homework ones. I would say these were way easier than the ones in class.
Are you sure you want my homework?
It's kind of empty.
Empty.
Doesn't have much stuff. I mean, there's a proof,
I
right?
have a proof, I just think that's smaller.
I see letters, random letters.
There's no
8
random.
F B D E A C. What does that even mean?
It just made sense in my head.
You literally wrote for the answer for number 2. You wrote A C 8 F B D E.
Well, it's because you're supposed to put the order of the.
Oh, then he did it right then. How
Yeah,
come I didn't call it out that way? Oh, because it was a proof. It was a proof. That's why. That's why. That's why. All right. All right. These are all hard proofs. Every one of them's hard. Homework. There's 8 of them,
oh, 8, okay, I can do that.
and it's not too bad. The homework, the in-class stuff, it is hard. If I were a clicker, why would I be over there?
Why is there no homework for Wednesday? Did I write it somewhere?
Maybe you wrote it on Tuesday because you probably wrote Tuesday's homework on Monday because we didn't actually do.
Hey Siri, what happened in history on October the 8th?
The bird started flying.
Hold on. Let's see. She says Pakistan earthquake 2005, USA earthquake 1983, Great Chicago Fire. You probably heard of that. 1871. Apparently, it was caused by
Matches.
a cow kicking over a lantern in somebody's barn.
Oh.
A lot of destructive things happened.
Boring. Not much happened on October the 8th. Tower of London Post Office opens in London in 1965. I'm not sure why that one's. These are all boring.
The Roman Empire fell.
Okay. All right. On to proofs. More fun.
Or the Greek Empire fell. Or the Trojan Empire fell. Or
All right. There's lots of ways to skin a cat, as we say. Right. That cat's not too happy. I'm going to show you a method, right? I'm not going to claim that these are the only method to solve these proofs. These are. Why is it starting on number 3? Why does it say number 3?
That's our number 3.
Yeah, but where's number 1? These are not the drawers you're looking for.
I say,
How can this be
okay.
2 in a row that I've messed up? I know my other one isn't messed up, so I'm going to switch to, you guys got the homework copy down. Why is that proof number 3? That's crazy.
Because math teachers don't write? Is that it? Am I right?
No,
Do I
but
win a prize?
I'm not sure why it's the same presentation. I just changed the homework. All right. There we go. We'll use theirs.
Cpctc.
Oh, you're already memorizing what the answers are. Okay.
I just forgot. Let's do this.
Oh, I got to share this with Ben. New share.
I can kind of see it.
All right, let's see. So if they're congruent to each other, that means.
Can you see it now, Ben?
Yeah.
Box 1? Okay.
Which means A and D are congruent to each other, which means that.
Well, let's step back one step. What's this say? The proof part?
They're right triangle. Perpendicular.
So how do we prove that there's a right triangle?
By splitting of the atoms in the triangle.
Do you see any, now I agree that there's red numbers here. Do you see any values inside those triangles?
Yes. The
Where?
line is the line in between right in the middle of it. You can turn it to a right.
It looks like it's a right angle, doesn't it? Right?
Yeah.
But we can't go by the picture. So do you see any values inside?
No.
How many triangles are there, by the way?
2, 3, 4,
You better keep counting.
4, 5,
5.
Keep
6,
counting.
7,
Keep counting.
8.
There's 8.
Why? How's there 8?
Well, you can see the 4, right?
Yeah.
Then you got the top one, you got the bottom one, and you got the left one, and you got the right one. Okay? So there's 8 triangles there. How do we show that something's perpendicular? You got to show that there's a right angle. So how do you show there's a right angle if there's no numbers?
By right angles.
So this is the problem. Period 1 could not figure this out. Let's see if you guys can. How do you, if I give you no values, like I'm not saying that angle 5 is 40 degrees. If I give you it's 40 degrees, maybe there's a way to figure it out. But I gave you nothing. How do you figure out that they're 90 degrees?
Definition of a right triangle.
Okay, so how do I figure out it's a right triangle?
Because of a theorem that we did.
We don't have any theorem that says it's a right triangle.
Oh, okay. Well then.
Yes, we will.
Because
How do you figure out something's 90 degrees? This is a hard one. Period 1 couldn't get it. 2, I'm sorry, I teach John period 2.
if you
Ben, you got any ideas? Ben actually went for cookies.
if you split it in half, you might get somewhere.
What do you mean split in half?
From the middle, just chop it off, make a Lego brick.
There might be something to splitting in half thought.
But I don't know how that helps.
I need to figure out that one of those angles is 90. If one of those angles is 90, right, then I can say that something's perpendicular. So how do we figure out if something's 90 degrees?
By measuring it.
Without a protractor.
Yeah, I do. It's just not on.
Nothing? Nothing? What do you see?
No.
A line, they share the line.
Yeah, that's what I was
So
saying.
it's congruent to itself.
So if it was, what's congruent to itself?
The two triangles.
B,
Okay, well that's reflexive, right? You weren't thinking what I was thinking.
and BCD.
Why did I draw a straight line?
Because it's a right line.
What?
It's a right line.
What's a right line?
It's a line that goes straight up 90 degrees. That's a right line.
The
No.
line can't be 90.
Yes, it can be 90 degrees.
Why?
Yes, it can. If it's on a plane, it can be 90 degrees.
Well, yes, the relationship between the line and the plane can be 90 degrees.
Yeah,
Why did I draw a line?
because you can, but because
2 angles add up.
oh,
180.
Okay, so what?
So angle 3 plus angle 4.
Okay, so how does that make 3 or 4 90 then?
if you subtract it by 90 or by a number, you get 90.
So what do I need to prove?
And
Bisect would not necessarily mean it's 90 because I could bisect this one like that and it's not 90 degrees, right? So if that's the segment right there,
You need to prove what 3 and 4.
what good would that do?
Because then you can tell that they're both the same.
Because
And if they both add up to 180, then
that's how we're going to do it. So if we show that angle 3 is congruent to angle 4, they're both on a line, that means they're both 90 degrees. Therefore, that would prove that these two lines are perpendicular. Okay, so we've now figured out what we need to do. We need to show that angle 3 is congruent to angle 4. That's what, even though this is the end of the proof, what we really need to show is 3 is congruent to 4. Okay, McKinley, you follow that logic?
yes,
All right, well, what's our standard go-to thing of showing that two things are congruent? 3 steps. What are the 3 steps?
Cpctc.
That's the last step. What's step 1?
Prove they're congruent.
That's step 2.
Figure out what kind of triangle they are.
What's step 1 of the process of showing that two things are congruent? Showing that the parts are part of
Information.
2 different triangles. Are 3 and 4 part of 2 different triangles?
Yes.
Which triangles?
AB.
So basically left side, top, and bottom, those triangles, right? So I need to show that those 2 triangles are congruent. If I can do that, then we say Cpctc, and most proofs we're done. We just have one extra step that says, that, oh, because they're congruent, they're 90, therefore they're perpendicular. Okay, so can we show that ABO and ADO are congruent? Oh, by the way, what's the, let me catch up. That's the given. So can you show me that those 2 triangles are congruent now?
Well, you could do
I could do reflexive. Okay, so if I did reflexive, AO is congruent to AO, I get one tick mark right there. Can I now say that those two triangles are congruent? Because I need something else. I got an A, I got an S. Well, that's what we're trying to do, is show that 3 is congruent to 4. So even if I were to show that, that's not going to help me show that the two triangles are congruent. Because 3 and 4 is what I'm trying to show. That's why I can't show that 3 and 4 right now. So we're at a problem. We can't show that the upper left is congruent to the lower right. So how many triangles did I say were here? So maybe instead of showing those triangles, we might show some other triangles, and from that we might get back to the pieces parts through Cpctc that 3 is congruent to 4, maybe. Okay, what other triangles do you see there? So BAC, so you're talking about the top triangle and the bottom triangle? So let's look at the top triangle and the bottom triangle. I'm going to take away this tick mark. Top triangle, the bottom triangle. What do we already have? We got two angles. We can do the reflexive and get ASA. That's what we're going to do. So I can say that AC, we're doing top triangle, bottom triangle. That's reflexive. Therefore, those two triangles by ASA. Okay, great. Top is congruent to bottom. What were we trying to do? I was trying to get 3 is congruent to 4, and we said to do that I need to show what? Which two triangles? The top left, bottom left are congruent. And we just showed that top's congruent to bottom. So what part of the top and the bottom could I use for top left, bottom left? I just showed that this triangle is congruent to this triangle. What part of this triangle is part of those two triangles? What name? AB and AD are these parts of this triangle. Therefore, by Cpctc, they have to be congruent. So I can say that, right? So AB, AD, Cpctc. We're almost there. One more thing we left off that we said before. The reflexive property for AO, right? And then SAS. And then what were we trying to show? And before that, in order to do that, we need to show that which ones? 3 and 4 are congruent. So 3 is congruent to 4 by Cpctc, and then that's the whole proof right there. So the reason is that, you know, if two adjacent angles are congruent and they're on a line, then they got to be perpendicular to each other. With two lines. Because it makes 180 degrees. So they're right angles. If 3 wasn't congruent to 4, then you can't say that they're perpendicular. So this one we didn't have to physically split, even though I drew this one like this one. You didn't have to necessarily do that, but you certainly had to wrap your brain around the physical geometry of that shape of 8 triangles. And I would say that that's probably the level of a honors proof right there. This one for sure. Some of the ones we'll do today, they're even tougher, you guys. I probably wouldn't put on. So we're going to do them just so that we can mess around with them. All right, QED. You don't need to write this down in Book of Truth. So there's lots of types of proofs. One type of proof, and this isn't really necessarily a different type of proof in the sense of mechanics. It's different in how it's presented. A paragraph proof is basically me talking to you. Hey, let me prove this to you. I use complete sentences. I'm often only focusing on the main idea. I omit some facts. right? Some things that are obvious, right? Because of Cpctc, these two things are congruent. Well, I might skip that part and just say, hey, look, the two triangles are congruent, therefore I can say this, and I might skip the, oh, by the way, the Cpctc. If you take any math at the college level, right, almost all proofs that I've ever seen for geometry are always done in paragraph proof format. Two-column proof is a high school thing. It's great. It's good for teaching. But when we start doing some more challenging ones, not because paragraph proof makes it easier, it's just that we don't, we like as human beings to read things in paragraph form. So I'm going to show you that same proof in paragraph form. It's going to look like it's more complicated. It's the same thing. So here's that same proof that we just did in paragraph form. Since we're given that angle 1 and angle 2 are congruent, angle 5 and angle 6 are congruent, and triangle ABC and ADC share side AC, then triangle ABC is congruent to ADC by SA. Therefore, the corresponding parts AB and AD are congruent, looking at ADO and ADL. The nice thing is I can throw those extra words that assist you into understanding the proof. When you write a two-column proof, there's none of these, therefore, corresponding parts or looking at. I mean, I don't have those words in there. Hey, now I want you to look at this triangle. I can put that in a paragraph proof, right? I can't. I can't put those in a two-column proof. So that's a paragraph proof, and they're pretty. And if you open any geometry book, you're going to see. And by the way, this is how Euclid he did paragraph proofs as well too. All right, lots of ways to skin a cat.
What happened to that poor cow?
Well, he doesn't want to get skinned.
Why would anybody skin a cat?
Why was anybody skin a, I don't know, a fox?
Reasons
Why do people skin a deer?
to eat it.
Well, you don't eat the skin.
To get rid of the skin?
You use its fur to make clothing.
But why would I want to wear a cat? I mean, there's just not enough.
This is straight up your alley, brother. You're the one that wanted to make a mountain of cat hair. You don't remember that? Seventh grade?
Vaguely.
Okay. This was like you're saying for a month. What if I had a mountain of cat hair? Okay.
What if I did though, huh?
This is a little bit easier of a proof. A little bit easier of a proof.
A little bit easier. All right, let's see. So we use some math to do some math, which gets you to the answer.
All right. I always, on the more complex ones, I don't even look at the given. I just go right to the end. So what's the end say?
ASDT.
I'm trying to show that this piece is congruent to that piece right there. All right. Tried and true technique. How do you show that two things are congruent? Showing they're part of two triangles. Yeah. Then
There's 4 triangles there. I mean, 4, 5, 6.
then SAS, all that stuff, those 5 things we got. And then lastly, call it Cpctc. Okay. There's lots of triangles there. Which ones do you want to use to prove this? We got the big one. We got the one on the left. We got the one on the right. Which one do you want to use?
ASC and
EDT, so the ones on the left. Okay, let's see if we can prove the ones on the left.
BF.
So here's the ones on the left right here. We got a side and we got this arc right here actually goes the entire way across. It says BACEDF. So what?
I have 11.7. Wait, we're going back to 4.7?
Oh, I just gave you tomorrow. Sorry.
Yeah, I was like, wait, I don't feel like 3.
Well, you got the bonus point.
Oh yeah, I forgot we're in geometry, so we go much slower than other classes.
Well, we don't, actually, we go faster. We're already on chapter.
Yeah, algebra wasn't like 2.2. Yeah.
No, they're not. No, they're on chapter. And who?
Hannah, the other class.
Zimmerman?
I don't know what her last name is.
All right. Okay, back to this. So this arc goes across the entire thing. So all I have on the left ones are just that one side.
No, but you could use reflexive.
Oh,
and
there's no reflexive there.
yes, there is.
These two triangles aren't together, they're separated.
Well, you can DT equals DT. Yeah, DT equals.
Okay, but they're trying to prove,
Wait.
Jack, they were trying to prove that this triangle is congruent to this triangle.
Yeah. So then if B is congruent to S.
I guess what I'm saying is we got nothing.
We gotta draw something.
All right, so maybe another set of triangles. If it doesn't work for that, then go to another set. Which one do you want to try now? CSA, so the ones on the right. So let's see if we can say something about this triangle and this triangle. Clearly, we already got two sides.
Yes, and then you.
If we can only say something about DT.
Yes, there is something about those. They're clearly angles. Clearly, they're 90 degrees. They're
So once again, the arc at the top, which, oh, by the way, even if we had, would be ASS. An arc at the top goes across both of those angles,
Well,
so
even
we
if
don't
you-
even have that
Yes, you
this
do.
angle is congruent to this angle.
Well,
Maybe, it turns out it is,
it is.
but we don't know that yet. So, strike two. Do we got any other triangles we can look at?
You have to build one. The big triangle.
The big triangles. Now let's look at the big triangles.
Side. No, because you don't have ET and DS.
Side, angle, side.
Yes, I was saying that. from the
Side,
beginning.
angle, side.
Oh, easy.
So the two big, I gotta catch up. The two big triangles are congruent by side, angle, side.
But that's what I've been saying.
I didn't hear you.
But I think. But it's.
Okay.
To improve that.
So once you show that we would like to show that either the left triangles or the right triangles are congruent, because our goal is to show that DT and AS. So if we can show that those two triangles, the left ones or the right ones, are congruent, then we can call Cpctc and we're done. So which ones you want, left or right now?
Left.
Okay, if we look at the left ones, what did we just prove?
That there's
I'm going to draw it. We just proved that that triangle is congruent to that triangle. So now we can use Cpctc and say anything about this one.
Oh, F is congruent to C. Angle F is congruent to C. And then
Because
angle S.
notice, this and this would be part of the right triangles, not the 90-degree angle, but the correct triangles we're looking for. So we could say that C is congruent to F by Cpctc. Okay?
And then we can say that because C is congruent to F, then DTF is congruent to ASC. Then we can say because of SAS, and then
See the
CPC,
SAS?
and then CPCTC.
And that's how it ends.
I was right.
Ben, are you with me or are you still eating cookies?
Said I was eating cookies.
Because we asked you a question about 4 minutes ago and you didn't say anything.
Oh, probably because I was getting a drink.
I knew it. We were betting it was
I
cookies.
mean, I'm eating cookies.
Well, I would be eating cookies if I were home.
I'll be eating donuts.
Well, you're not me and I'm not you, so therefore I'm not eating cookies.
Okay.
Can I go back to bed now? So therefore you are eating cookies.
By that logic, though, that means that anyone that's eating cookies at the same time is the same person.
And also by that logic, it means that if you're opposite to Mr. C right now, then that means that you're eating cookies right now.
Okay, I have a question.
Is it
Sir, I
on
have a
this?
question.
Go.
Yes. No, I do. It is on this.
Go.
What does CPCTC stand for?
Congruent parts of congruent triangles are congruent.
And Jack's wrong.
What? Oh, corresponding parts of congruent triangles are congruent.
Now he's right.
Sir,
So-
can you repeat that? It's hard to hear other people.
CTC is the catch-all, and because it's so many words, we use abbreviations. So basically the idea is this. If you show that two triangles are congruent, then all of their corresponding parts to both triangles are congruent to each other. Meaning that the left side is congruent to the left side, the top angle is congruent to the top angle. So that the saying is that the corresponding parts of congruent triangles are congruent, CPCTC. All right. Of course not. Okay, here comes one. Usually kids will miss this simply because they don't look closely
They're
enough at the
vertical.
picture.
I knew it. They're vertical. Yes, finally.
Yes, there are some vertical angles here. All right. So I'm going to go again. I look at the finish before I even look at the start for the more complicated ones. What am I trying to show?
AX congruent to AY.
Where is AX and AY? No, this one's different. Where is AX and AY?
AX is in the middle of. Yeah, they're right in the
All right.
middle. which means
So
they're right.
now the question is, which triangles do we need to show are congruent in order to claim CPCTC?
PAL and not P, APL and ANR.
So APL does not contain AX. I need a triangle that contains AX and AY.
AXL and AYK.
So it turns out that those aren't the same triangles.
Yes, they are the same.
So
Oh, wait, no, they're not. It would be.
you look at AXL, it's got one tick
No,
mark.
I see my mistake.
So
it's
it's-
AXT. It's AXT. It's AXT.
Oh, you want to do two tick marks and two tick marks?
Yes.
Okay, we'll do McKinley's one. We could do it the other way as well too. It doesn't really matter, but I will say, look at me. This is the bow tie. What they've done is, instead of it being congruent like this, they flipped it over like that. You see that? That's all they've done. All right. So that's usually where, if I were to throw this on a test, the mistake would be made. So just make sure that you, in fact, realize we're going to do top left to bottom right, because that's the one with two tick marks. All right. Can you prove that those two triangles are congruent right from the start?
Yes.
Yes.
All right. Show me.
Angle PAX is congruent to angle YAX,
YK.
YK because of vertical angles.
I agree.
And then because of, wait,
Yeah. What reflexive property?
Vertical reflexive property.
No such thing. Yeah, then there's our problem.
okay, oh, I know what to do. Well, couldn't you just say the angle NAK is congruent to angle PAL, and then by SAS, then they're congruent, and then
One more time. Say it again.
the angle NAK is congruent to angle PAL because of vertical.
Because instead of looking at these triangles, instead let's look at
the big triangle.
the big triangles. Yeah, let's do that instead.
That's what I said at the beginning.
Oh, no, you got it right. You said vertical angle. I agreed. I
And then
gave
you
you.
do SAS.
All right, so what's my first step besides giving?
You do vertical angles.
Okay, so which vertical angles?
PAL and NAK.
PAL. Just remember, you're starting going from 2 to 1, so we technically want to go PAL, KAN. All right, so PAL, KAN,
Wait, you said the last one, Cpcc.
because it's got to be.
But
That's how all proofs end.
Palkin. What the heck is a Palkin?
Palkin. PAL is a video format for Europe.
And it's also a slang for buddy.
That's true. Okay, now what? What are we doing now?
SAS.
So
Which
P.
means PAL is
We can,
congruent
and if you haven't
to
ever
PAL is
noticed
congruent to
this,
KAN.
once you write an angle, the triangle is the same order of the letters. Okay? So triangle PAL, triangle KAN, because SAS.
And then, because of Cpctc, and K is congruent to PL. That's not going to help so much.
Say that
Oh,
because of
I
CPC,
can-
you can say that APL and NK
Oh,
are
oh,
congruent.
So how about P and K?
Yeah, angle P and K
So
and
P and
angle
K?
N and L. So then
And
you can
then
prove
we
that
can
those
say
are then
that it's
by ASA.
Okay, so we want to what? P and K, and then what else do we need?
And then we can say nothing else.
Is that all we need?
Yeah, that's all we need.
I just remember this arc right here is for the whole thing, not for an
I
individual
know,
thing.
that's all we need though, because we can still do vertical angles.
So we need one more statement then.
So
Okay,
then
fine.
you can
Vertical
say that
angles.
PAX
PAX is
and
congruent to
Y.
Y, and then you can do by ASA.
K Y.
ASA.
Pax
and then
K.
CPC.
Okay. Then we can claim.
Pax is congruent to K.
Then we can claim
Triangle Pax is congruent to triangle K. but
because of.
ASA.
Cpctc.
And as I claimed, that the proof ends with a Cpctc. So I mean, we tried to count it in period 2, how many times we've done this, and we came up with 9. We've done this 9 times to show that 2 things are congruent, show they're part of 2 different triangles. They could be angles, they could be sides, it doesn't make a difference. Show that the 2 angles or 2 triangles are congruent, and then simply call out Cpctc. So other than the first one, which was technically the same thing, we just had that one extra step of, hey, what makes it perpendicular? But it was still this kind of proof. And I'm just going to say, like, no joke. It's like the rest of the book. It's the same darn proofs over and over and over again, which is why when we get to spring break and you can't do this proof by yourself, you know, then I know I haven't done my job as a teacher. For the regular kids, you know, I'll give them to spring break. For you guys, you should have this by Thanksgiving, right? Being able to do these proofs.
I already do these proofs.
No, but I'm saying if I were to just if I gave you this proof tonight for homework, they're not this hard. But if I were to give you this proof, I would bet that, you know, you'd probably come back half of you with questions, like, how do you do this? Well, it took us a while. All right, next one,
Why on the sheet does it go from 5 to 9?
because I made a mistake.
But no, it could be a 6.
Okay, by
if you go
SSS,
under
those
it.
two.
It could be a 6, and sometimes I write upside down.
By SSS, LBO is congruent to JBO.
By what?
SSS.
Okay, so before we do that, that's true, by the way. By what? SS? Okay, yeah. Before we do that, let's see if that's even something we want to do. So what's the end statement?
3.
So I can think of 2 ways to prove that 3 is congruent to 4. What are the 2 ways?
Alternate angles.
No, there's no parallel lines there.
I know, but still. I mean, it might be.
Yeah. LOA and
One more time.
prove that triangle LOA and
So prove that the top right is congruent to the bottom right. Okay, then by Cpctc. There's another way.
prove that the whole top triangle.
Top triangle congruent to bottom triangle, right? One of those 2 ways. Those are the 2 ways that strike me right from the start. Okay? All right, so let's see if we can do either one. Let's go with Jack's first. Okay? Oh, or no, wait a minute. Let's just see if we can use the, can we get anywhere with top right and bottom right? Can we get anywhere from the start?
No.
We got a side, right? Oh, we also got
We have
reflexive.
sides.
So we got 2 sides, side, but nothing about angles. Or do we? Is it isosceles? No,
it's not very good.
not vertical. So we got nothing. All right, let's look at big triangle, top and bottom. Can we say anything about that?
We've got side.
We got side and then reflexive, another side. So we got side top.
Oh, we have side angle. We do have SAS because of the VOVO.
Hold on, we're looking at top triangle, bottom
I know,
triangle.
but you can prove about top triangle, bottom triangle because of the SAS. Because if you prove that the 2 triangles.
Where are we getting an A from?
Because of the 1 and 2 are congruent because of VO and VO.
Where does it? Oh, hold on. You're jumping ahead. We're trying to prove top triangle, bottom triangle. So the question is, can we get anywhere besides S and S?
Yes.
He's actually right, but he's not thinking.
I'm
Without
not thinking
doing
right.
anything
I am
else.
It's
thinking right.
no, you didn't let me finish my sentence. I wasn't going to say you're not thinking right. You're just not thinking sequentially, right?
Okay,
So the- so
VO
the-
is congruent to VO.
The basic answer to the question, can we prove top is congruent to bottom at the start is no,
Yes.
meaning we have to continue and look at something else. Now let's look. What's the only thing that's left now? The left, which is what he wanted us to try from the start. Okay. All right. So let's look at this. How about this triangle? This triangle. Why?
Because of SSS.
Because of SSS. So okay, we get that. So we're gonna make that statement. So we gotta have the reflexive thing to get our 3rd side. So now we can say that those 2 triangles are congruent.
And then what is congruent to?
Then we can claim that 1 is congruent to 2. Remember, now we're going to try top to bottom. So 1 is congruent to 2. You guys are talking too fast.
So then LB is congruent. LBA is congruent.
Because
to
of
SAS.
because of that, we got to make that reflexive statement. So you got to have a BA. Yes. Okay. And then we get SAS. And as all proofs end, Cpctc. And I am exaggerating about all proofs. It's not true, but you're going to see this. It's not that it ever gets boring. It's just that you're always ready to do this. Okay, cool. Let's see if we can get the last one. What's the only triangle congruency theorem we haven't used so far?
I don't know. I wasn't here.
We used SAS, we used SSS, we used AAS,
It's HL.
HL.
Or
And
AAS.
Hypotenuse up.
Oh yeah, I can see it.
as soon as you see the right triangle, I'm not saying it's guaranteed to be HL, but you start thinking, oh, maybe there's an HL.
Yeah, it could. Yeah.
It is HL,
All right, hold on. We're trying to get D and F.
but it's also AAS.
Yeah, it could be.
Wait, but
How many triangles you see?
Box 5 is supposed to be about 6.
Say what?
You have box 5 is supposed to be about 6.
I know, I messed up.
6.
There's 6 triangles there, all right? So we got little tiny ones, medium ones, big ones. All right, which ones you want to try to prove? Oh, by the way, if we get to the medium ones, gets us nowhere. It may be a which one we want to use? Middle?
Middle one.
So the medium ones, that's not going to get me to the answer, but maybe it helps me. So clearly we see, let me catch up.
CB is congruent to GQ.
So we see vertical.
Or,
So because of HL, those 2 triangles.
well, not because of HL, because of
Where do we get
AAS.
the
Oh,
L
AAS.
from?
Yeah, it's AAS.
So we got AAS, I agree. Okay. So we didn't use HL for that one. Okay. So let's see if that's the case, then we could show that.
I can do it.
That's congruent to 3 tick marks. That's congruent to that.
And then DBC is congruent to EPC.
We're
because
done,
of-
buddy.
What? What?
Hypotenuse leg.
Yeah. We're done.
We don't need to say anything about the angle.
Why not?
Well, we do in the
Yeah.
sense that we got to claim it's a right
Not
triangle.
if it's rectangle.
Okay, so we would have to put something there that says that that's right, but since that one's right, then the other one's right. So hypotenuse leg, Cpctc, that's how that one's done.
How many postulates or
We
definitions?
didn't write.
We didn't write anything,
Oh, thank
but we're good. It's just there's 6 proofs tonight for homework.
you.
And
Increase.
Micah said that he did the whole thing in class during period 2, and he said that the proofs were way easier than any one of the ones that we just did.
Oh, cool.
Yay, that means I have,
Of course, he could have gotten them all wrong.
oh, yeah. There is always that clear. But then again, I might be reliving this day.
Jack, are you in trouble?
No, why?
I'm just wondering. So everything's good?
What happened? Why is everyone saying Jack's in trouble?
Did you not hear me talking in the first part of class?
No.
One proven.
All right, Ben, that's it.
I need to see the homework again. Isn't
Okay.
it 1 through 8 all?
See it?
Homework. I need to see the homework.
There it is.
Thank you. All right, goodbye.
See ya.
Bye.